function optimization was kind of completed. So today we shall take up another topic on the Quine-McCloskey algorithm. I'm just looking for this diagram. Yeah. Just a minute, please. Okay. Yeah. So just to confirm, I hope I'm audible. So can you please confirm?
Yes, yes, you are audible, and slides are also visible.
Okay. I mean, right now I'm just showing this diagram from the web page. So yesterday, in fact, there was a discussion on this. I'll just take this discussion further. So in this diagram, this one is opened in, I mean, I'll just try to save it. I don't know whether this can be opened using external. I'll just try. Let me just use LibreOffice. I hope I'll be able to. It does have facility for rectangle.
Sure, I think the pen can be used here. The stylus.
Yeah. Actually, I'm just trying to, but it is. It is. Can I have draw a line?
You have to go to insert, then figure smart shapes, insert smart shapes.
Well, I am.
This will do. This will do.
Able to draw a line, but it's a straight line. Okay, then let me just try this. Sorry, I'm not prepared for this. That's the problem. Anyway.
Actually, CRM, you can use the stylus and.
No, I'm using the stylus only. but I'm not getting anything to draw a freehand line. I mean, this is coming out to be a straight line. Yeah. Anyway, so doesn't matter. So I'll just underline only. So in this diagram, I hope you are able to relate this to a Boolean lattice. Is this a Boolean lattice? Yeah, I'm just asking this question. Is this a Boolean lattice? Yes or no?
No,
Why? Why not?
0 is not present.
0 is not present. Yeah, so 0, so you can just assume that 0 is present actually. They have not shown it, but we could very well assume that, 0 is present. So let us say that is 0. Alright. So of course, if that is 0, then you would have, this sort of lines from, okay, I'm just drawing some, this has become a rectangle. What is happening? So you will have a number of such lines. It's not so convenient. I don't know why it is becoming a rectangle after that. But anyway, I'll just I'll not draw too many lines. I just, that's enough. So, yeah. So you can have a number of lines like this, okay? Yeah. So, you can have a number of lines like this. So that is just not shown because so unless the switching function is false, you don't need that node. So that's why they are not shown. But it is really that Boolean lattice only. The zero node or the false node was missing. That's all. So now, if you can relate this to so you remember the stone construction. Do you remember how that stone construction was done? So for stone construction, what is the basic step in stone construction? Can anyone tell me? Can anyone recollect the basic step in the stone construction of a Boolean lattice? Yeah? So from level I, how do you go to level I plus 1? I mean, you start at the atoms and then you go to the higher levels. How do you do that? So you take two nodes. Okay, you take two nodes like A bar BC and A bar BC bar, and so that are adjacent. You basically take two nodes that are adjacent and join them. So if you see, that is exactly what is happening. Each node in the next higher level is being created from a pair of can be created from a pair of nodes from the lower level. So if you look at this, for example, A bar B is created from A bar BC and A bar BC bar. Okay, so these two are adjacent. So if you see B bar, or let us say C bar, let us say C. So C can be constructed from many pairs, not so how many pairs? So if you see, there are 4 green lines. So you can create C from 4 C2 pairs. All right, you can create C from 4 C2 pairs. All right. For example, you can create C from AC and A bar C. You can create C from A bar C. What is this? One second. BC and BC bar. I'm not sure. Oh, okay. So you're sorry. Okay, no, not from all pairs. Sorry, I made a mistake. It has to be adjacent. Pairs of adjacent nodes. So you can create C from AC and A bar C. You can create C from BC and B bar C. So you can create C in multiple ways. All right. You can create C in multiple ways. So from adjacent pairs of nodes in this at this level. All right. So if you if you do that, now what you see is that you have some green nodes and some blue nodes. So what can you say about the green nodes and the blue nodes? Yeah, can anyone tell me? What can you say about the green part of the figure and the blue part of the figure? Anyone? Yes? You should be able to tell me. I mean, see, the green part of the figure, those correspond to, you can say, the onset of the function. That means you look at the base actually. The function is constructed from the base. You have done Carnot maps. So what you have seen is that you have an onset. So the function is on for the green nodes ABC, A bar B, A B bar C, A bar B C, A bar B C bar, A bar B bar C. Okay, so these green nodes correspond to the onset of the function, and the blue nodes correspond to the offset of the function. So this one is presumably a completely specified function. That means you don't have any don't care elements in this. This is completely specified. Now if you take all the nodes and edges together, that corresponds to the complete stone construction. All right, that corresponds to the complete stone construction of this entire lattice. All right. But if you restrict yourself to only the green nodes, all right, so in other words, you disregard the blue parts. All right, you disregard the blue parts. In that case, what happens is that if you disregard the blue parts, then you are actually again doing a stone construction, but you are restricting the stone construction to the onset of the Boolean function. Do you get that? Yes? Are you okay with that? Someone please respond. Nikhil, are you there? Nikhil? Abhishek Rajesh? Abhishek Rajesh, are you there? Hello? Varun Gupta, are you there? Yeah?
Yes, sir.
I think some people are just, they have left this thing. They've just left the teams running. I don't think they're attending anyway. So,
I'm here.
anyway, what I'm asking is, so do you understand that you're actually doing that stone construction only, but you're restricting yourself to the green nodes. So just think that the blue nodes are not there. So you're carrying out the stone construction from the green nodes only. So if you see that you're just if this entire lattice which is shown, that results from the stone construction starting from the atoms. Alright, these are the atoms, as you can see, just above the bottom node, that is false node. Alright. So what is going on? Can you just see what is going on? So you are starting at the atoms, okay? You are starting at the atoms, then you construct the nodes at the higher level by performing join operations. All right. So this join operation leads to a reduction also, because as you can see, the number of literals. So you are reducing not only the number of terms but also the size of the terms. For example, if you look at A bar BC, all right, and A bar B bar C, if you join this, you get A bar C. So if you take A bar C, you no longer need A bar BC and A bar B bar C, because both of these are covered by AC. All right. Is that okay? So I'm not getting any responses. Please respond. Obilash, are you there?
Yes, sir.
Yeah, so please respond. So let me give you an exercise. I mean, you people do that exercise. So we'll take up what you had done last time. I'll just give you an exercise from there itself. Let us just take a Carnot map of 5 variables. Okay, so you have this Carnot map of 5 variables. All right. So, or will this be too much? Let us just see. This one. Okay, let us look at a slide. Yeah, okay, I think let us take this. This will be more manageable. Let us take this Carnot map. Let us take this switching function. Okay, let us take this switching function. You had done this in the class yesterday, I think, isn't it? 0, 5,
Yes,
7,
sir.
8, 11, 13, 14, 15. So why don't you construct the Boolean lattice? So how many atoms are you going to have in the Boolean lattice for this? Yeah. How many atoms?
16.
You'll have
2
16
power.
atoms. All right. You'll have 16 atoms. So and then you restrict. So you just, I mean, you restrict yourself to only these atoms. So these mean terms are actually atoms in the Boolean lattice, right? So you just restrict yourself to these atoms, and why don't you draw this kind of a diagram? Why don't you draw this kind of a diagram? Okay. Do it now. Do it on a piece of paper and let us see. Do it right away. You do it and I'll take a submission now. I'll just create an assignment and you can submit this right away.
Sir, could you please show the figure?
Yeah. I'll just tell you. You'll see it better. See, I'll show you from where I got it. See, just search for Queen-McCloskey algorithm. Just search for Queen-McCloskey algorithm and you will get this figure in Wikipedia. I've taken it from there only. I think you will be able to see it better in your own on your own computer. Okay.
No, sir, I am talking about the assignment.
Oh, you are
Question
talking
that-
about the Carnot map. It is
Yes, sir.
also available in WBCM. I have uploaded the slides, but I'm showing it to you. 1 minute.
Okay. Sir.
You can. 1 second. Sorry. It is. Here, you are talking about this one. Yeah, you can see it in you can
Yes,
see
sir.
it from the slides in WBCM. These are already uploaded. I think, yeah, I think, let me just check. I think these are uploaded. Yeah, it is. Oh no, slides are not yet uploaded. Okay, I'll upload the slides right away. I think there you found one mistake in the slides last time, isn't it? Yeah, you can download the slides from there now. Slides have been made available. You can see from there also. So please work it out and you can submit right away. All right. So all of you, please create this and you can submit right away. I've created an assignment for you to submit. So what I want you to do is you have to create such a diagram. So you got to just restrict. You don't have to draw the blue arrows. All right, just the arrows from the onset. So if you look at this diagram, what you'll see is that you have this onset, and then you're basically employing that stone construction principle to join adjacent elements at a level to create elements at the next level. All right. So like that you are going on as far up as possible. So for this particular example, you see a very nice aspect, that is this node C is covering all the nodes over here. So in other words, so this entire expression, so what is this expression? If you write this expression, I'm just writing it. Yeah, so the expression here is, if you look at the onset, this is ABC, A B bar C, A bar BC, A bar BC bar, and you also have A B bar C. And this whole thing, as you can see, is because if you look at what is happening here, all of these are being covered by C. So if you join these, eventually what you get is C. So that is very convenient. All right, that is very convenient. But when you do this, I mean, this is actually a very simple example. It is just designed. But when you do that, the result that you will get is far more interesting. So that's why I want you to work out that Carnot map example. So once you have worked this out, I'd like to I'd like to open it from WBCM and see what is there. So please do and submit as soon as possible. I mean, submit it now within a few minutes. No one has submitted as yet, so please work out and submit.
Sir, can you open the diagram once again?
This one or the other one?
No, sir, the other one.
Yeah, but can't you open it on your computer? This is from Wikipedia only.
Yeah, no, sir, I just wanted to ask one thing over here.
Yeah, sure.
Can you explain the A bar B part, the other dark green?
Just a minute. Which one?
A bar B.
A bar B. This one.
Yes, sir.
This one is coming from these two nodes, right? A bar BC and A bar BC bar. It is the join of these two nodes. Is that no? What was your question then?
Like, sir, C is covering all of them, right?
Yes. Oh, no. Okay, you're right. It is not covering all of them. Sorry, I made a mistake. It is not. So this is there. Yes, yeah, that is a good thing you pointed out. I had missed it. Yeah. So yes. So in fact, what I had written was wrong. I had written it from that diagram only. So I have to add that. Yes. Yeah, it was not covered. The remaining are covered, right? Yeah, the remaining are covered. So yes. So this gives you a very good. So I want you to do this for the Carnot map also, and yeah. So please do that and submit right away. Yeah, can you submit? I'm waiting for your submissions to come in. Then I want to see from there. Please submit.
Sir, I'm not able to open it,
Open what?
the assignment.
What do you get when you open?
Forbidden.
Oh, just a minute. Have I put the times wrong? Let me just see. February 18. February 18. February 18. Why do you get what message do you get? Forbidden. That shouldn't be the case. No, no, you only submit. You go to this students, because I have not loaded that HTML file. I have not loaded the assignment file. Hello. You only submit. Just try
Okay,
to
sir. Okay,
submit.
sir.
Yeah. Because I have not loaded the assignment file. I have not. I've just told you orally. Just submit quickly. Okay, someone has submitted. Others also please submit, because I'm going to assign some weightage. I'm going to put some marks for this. So all of you please submit. Who has submitted? I'm just looking for Yeah, Aryan has submitted. Okay, so this is his submission. Okay. So let me open this in let me open this in Exona. Okay, so I've opened his submission in Exona. So let me just, so this is actually just, okay, yeah, so he has actually marked out. So these are his atoms. These are his atoms. So this is really what is going on, you know. So what you're doing is you are taking this. So where you have just two, there is no problem. So this one and this one you are joining. Or let me say, let me not do that. If you see now BD is coming from, so here it is probably a bit instructive to do that. So BC bar D and BCD, these two are adjacent, all right? These two are adjacent, so he is getting these, and he is also getting, so let me just put it in a different color. So he has got A bar BD and ABD, I suppose. Yes. So ABD. So these two are there. All right. So these are two ways in which he gets BD. All right. But the important part is BD is covering, BD is covering, you know, this one, this one, this one, and this one. All right. So all four are being covered. Now, what is after covering BD? What is left is, you know, these are left behind. So these are being covered. So for example, this one and this one is covered here, and maybe I can get another color. All right, that is the same color as that. So this and this are covered here. So, well, there are okay, what you have done now, did you have the scope to construct any other nodes at this level? A, C, D.
हाँ वीरेंद्र
See, probably not. Okay. So, yeah, so these are the nodes that you could construct. So let us just compare it to the Carnot map. Let us just compare it to the Karnaugh map that we had. Where is the Karnaugh map? You just close it. Zero 057. I think this is the one we had, right? So yeah, so if we look at this diagram, if we look at this, so that BD is that bigger one which you can see, BD, then you have B bar, C bar, D, you have got ACD and BCD. So BD is here, and yeah. So as you can see, it is evident here and it's also evident here. So BD is covering 15. It's covering 15, but 11 and 14 are being left out. So it's not covering those. So these are being covered by this. You can say these intermediate terms, ABC and ACD. All right. So the way, I mean, okay, so this is something that you have done, manually. So how could we do it in a more procedural manner? How could we do it in a more procedural manner? So the exercise that you have carried out actually allows us to, just a minute, please. Hello? Okay. আচ্ছা ঠিক আছে হ্যাঁ ঠিক আছে আমার এখন ক্লাস রয়েছে একটু পরে কথা বলছি এক্ষুনি বলছি জাস্ট আমি ফোন করতে হচ্ছে না তো আচ্ছা ঠিক আছে আচ্ছা
CRM, you are muted. CRM, you are muted. Hello, CRM.
Yeah, okay. Yeah, so the exercise that was done here is actually very illustrative. So how we can go about it is as follows. You start at the level of atoms. All right, you start at the level of atoms. All right, and then you just join. You are basically doing a stone construction. So what you do is you join adjacent nodes at a particular level and join and generate the nodes, all possible nodes that you can at the next level. All right. Then from that level you go a level up, and you keep going up until you are able to go up any further. Okay. So that is the first step. So these are all. Now, if you remember the definition of implicants, okay, so what's an implicant? So I'll just take a few minutes. I mean, you're at the end of the class, I'll just take a few minutes. So if you have a Boolean function f, if you have a Boolean function f, and you have an implicant, and if so, this is a Boolean function, and this is P is an implicant. What it means is that, so it is written like this. That means you have actually come across this function, right? You have come across this. So what it means is that f is t when p is t. This is implication. F is t when p is t. All right. So if you see that all of these, mean terms in the onsets are implicants. All right. Whenever any of these mean terms is true, the function is also true. Okay. All of these are implicants. And if I just actually what he has already marked out. So if you consider these terms, these are also implicants, isn't it? Because whenever these terms are true, say b bar, c bar, d, or bd, or acd, or abc, whenever any one of this term is true, the function is true. So these are also implicants. But these implicants are also prime implicants. Why do we say that these are prime implicants? Because you cannot drop any more literal from these implicants without covering the offset. This one is not a prime implicant, for example. Why? Because you have been able to drop a, isn't it? You have been able to drop a here. You have been able to drop a to get this term. So this one is not a prime implicant because you have been able to drop a. So you can see that in all of these. So for example, this one is also not a prime implicant. Why? Because you have been able to drop a here again. You have been able to drop a here again. So this one and this one, if you look at this, you could drop a here again to get bd. So a bar bd is not a prime implicant because you have been able to drop a because there was another term, abd. So you have been able to join a bar bd with abd to get bd. Okay, so that's why a bar bd is not a prime implicant. However, bd is a prime implicant because you can't drop any literal from bd. If you drop any literal from bd, so if you have b, then you'll be covering terms in the offset. Okay, or so you can't. I mean, sometimes we say that you are growing the cube. Actually, just be a bit careful because when you grow the cube, you reduce the number of literals. So just you got to be a bit alert over there. So this is a bigger cube, and it's a bigger cube. It is very evident from the Carnot map that it's a bigger cube, right? This is a bigger cube. This is the cube BD. So this is the biggest cube in this. This is an intermediate cube. This is the smallest cube. All right. This is the smallest cube that you have. You have over here. So, and of course, the mean terms are really the smallest cube. This is the smallest cube in your cover here. This is your cube cover for the function. So what you can see is that each implicant can cover other implicants. A mean term is an implicant that only covers itself, but implicants at higher level cover more number of implicants at the lower level. So these implicants are just cubes. Okay, these implicants are just cubes, and you want to cover the function with, you know, with bigger cubes as far as possible, because as you can see, a bigger cube is easier to realize. You have been realizing functions, right? So you just you know, need a 2-input AND gate. Over here you need a 3-input AND gate. Of course, when you do the realization, you can have a NAND realization. So you know, this AND or function can be realized you know, using two levels of NAND gate. That is fine. So the first part is, you know, the first thing that you do is you know, very mechanically you can just do pairwise joining and generate all the prime implicants, because if any implicant is not prime, then this will get joined to generate a bigger implicant at a higher layer. Okay, so what you do is you know, very, you know, diligently, as you have done here, you join this you know, the elements at a particular level. So this happens to be level 1, of course. This is level 2, this is level 3. So, and you know, you also have level 0, which we are not considering. There you just have F. Okay, in the level 0 you are there. So you are joining elements at level I to get elements in level I plus 1. So you keep doing that until you can't go anymore. So elements at a level, at a particular level, which have not participated in a join operation to you know, create to generate an element at a higher level, those are your prime implicants. So first step is, first step, hello, first step is to generate all your prime implicants. All right, this is, and the next step is, so that is not evident from this, because here all the prime implicants are also essential. You cannot drop any of the prime implicants. So actually we should do another example where you have that option. So you might find that you don't need to consider all the prime implicants to cover your mean terms. So in that case, you can just choose some of the prime implicants. So basically there are 2 steps really. First step is generation of all prime implicants and the second step is covering elements, or I must say all elements of the onset with the least number of all right, these are the 2 steps. So I mean, we have basically worked out this step. We'll look at the other steps. All right. So okay, so I think we'll stop now. Thank you. Yeah. Okay.